This is a question on two current carrying wires, and you are to determine the resultant magnetic field patterns. So the answer to this question is B, and we can either memorize the magnetic field line pattern, or we can just use our right hand grid rule and apply it on each of the wires. So we are given that these wires carry current that is going into your paper or into the screen. So you use a right hand grid rule, point your thumb into the paper or into the screen, and you will get a few lines that is clockwise around the wire. So we are looking for few lines around the wire that is clockwise in direction. So if you look at B, this few line is clockwise. This few line is also clockwise. So that's the correct few lines. Another thing to check is that the few lines in the space between the wires is weaker. It's a weaker magnetic field strength, lesser few lines in the middle over here. And the reason is because in the space between the two wires, these two few lines are opposite in direction. So this one is pointing downwards, this one is pointing upwards. So in the space between the two wires, there's some sort of cancellation of magnetic field lines, resulting in a weaker magnetic field. So a weaker magnetic field is indicated by having lesser lines. When there's complete cancellation right smack in the center, if the currents are of the same magnitude, then there will be zero resultant magnetic field because of complete cancellation. So therefore, in sum, there are only two things to check. One is the clockwise direction of the field lines around the wire. The second is that the region between the wires have weaker magnetic field strength. And that's the reason why the best answer here is B.